All right. Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this lesson. Now, in today's lesson, I just thought I could make a quick video for my learners. And basically, what I'll be looking at is mathematical induction. So, in a nutshell, mathematical induction is basically a method that we use to verify whether a statement, and by statement I mean whether an equation is true or false. Okay, so maybe you have maybe prove that. Let me have it here. So maybe you are asked to prove that. Okay, prove that. There we have summation from n equals to 1 to infinity, let's say, of n, and this is basically equal to n squared. Okay, so suppose you have that. Okay, so basically what they are asking you here is to show that 1 plus 2 plus 3, or let's say up to n, let's not end at infinity, let's say we're ending at n plus all the way to n, this will give you n squared. Now, right off the bat, we can plug in some values to check if this statement is true, but we can prove this statement to be true or false by using mathematical induction. And basically, mathematical induction has 3 steps. So the first step, step 1, this is where you test, or let me say step 1, this is where you test for n equals to 1. Okay, you understand later what that entails. Then step 2 is the assumption test, where you assume true for n equals to k. So you are just replacing n with k. So this is where you're assuming. Then step 3, this is where you show. Okay, show true for n equals to k plus 1. Okay, so now we'll use this same question. So we have this very question here. So we'll start with step 1. So we'll say step 1 here, this very question. Should we even say that? Show that true for n equals to 1. So now, meaning that we get our sum here. So we can get our sum. So basically what we're going to do is say, where there is n, we're putting 1. So first of all, we write what we have. So what we have is a sum from n equals to 1 to n of n equals to n squared. So this is what we have. So we have 2 parts. This part that is expandable here, which is the same thing as what we have here. So for n equals to 1, we say for n equals to 1, where there is n, we put 1. So that will be the sum from n equals to 1 to 1, okay, of n. Then on this other side, we also put 1. So this will be 1 squared, okay. Then on this part, let me just move myself here and see properly. Okay, so on this part, we are summing from 1 to 1. So basically, a sum, we put in the values into this. Okay, so from 1, we are summing from 1, so that is 1, and we are ending at 1. So the last number that we can put in there is 1. So this would be 1. Is this equal to what we have on the left side here, which is 1? Of course, 1 is equals to 1. Therefore, true for n equals to 1. So that is step 1. We have verified that the statement is true for n equals to 1. Okay. Then basically what I was saying here, maybe you did not understand it. So maybe if we have the sum from n equals to 1, let's say to 3 of n, basically the expansion here means that you have the first number that you're plugging in here is n equals to 1. So that is 1. When you plug where there is n1, then plus because of the sum. The second number that you can plug is from 1 to 2, so that will be 2. You've plugged 2 here, and plus the number that we can lastly plug in there is 3. Okay, so that is the sum. Okay, so this has showed that the statement is true for n equals to 1 in step 1. We have to go to step 2, the assumption step. Okay, the assumption step. Step 2. Step 2, so step 2, this is where assume the statement is true for n equals to k. So this is the assumption stage. So we assume the statement is true for n equals to k. So we basically have what we've been given, summation. So we write that first. So summation from n equals to 1, infinity of n is this equal to n squared. Okay. Now for n equals to k, where there is n, we can put k. So this would be the sum. Sorry, we are ending at n. I don't know why I'm still up with the infinities. So we're ending at n. So this would be from k equals to 1 to k of k equals to k squared. So where there is n, wherever there is n, we're putting k. Okay, so that is the statement 1. And we should also make an expansion of this, okay, on this side of the sum. That is when we're dealing with series, always make that expansion. So expanding, you're starting from k, so k equals to 1, so that will be putting 1 here, which will just give you 1, plus the next number will be k equals to 2. The next number, you put 2 here, it will be 2. The next number will be k equals to 3, so we put 3 in this equation, which will give us 3. The fourth number will be k equals to 4, so that is 4. So let me say 4. So 4 plus, we'll go all the way to the last number, which is putting k here, which is k, and this should be equal to k squared. Okay, so that is our step 2. We're done with step 2. So step 2, there isn't much work. You're just replacing n with k. So basically that is what you're doing. So there isn't much work there. So you just assume that the statement is true for n equals to k because you've just replaced n with k. So step 3, show that it is true for n equals to k plus 1. Okay, show that it is true for n equals to k plus 1. So what you do is now you have your original equation, which is the sum from n equals to 1 to infinity of n, sorry, not to infinity, to n is equals to n squared. Okay, so you have this. Okay, now you're replacing in for n equals to k plus 1. So you say for n equals to k plus 1, where there is n, you're replacing with k plus 1. So this becomes, so here it will be k plus 1. So this would be k plus 1 equals to 1. We are summing to k plus 1. Then where there is n here, we put k plus 1. So this will be k plus 1 equals to, where there is n here, we put k plus 1, k plus 1, then squared. Okay. Then now, in this step, you're showing that this side is equal to that side. So it's either you pick the left side, you try to produce the right side, or the right side, you produce the left side, whichever way you choose. So it's up to you. The other way you can write the expansion here is that this is a sum. Okay, this is we are summing terms. Okay, so since we are summing terms, we are starting from k equals to 1. Okay, as from the previous step. So from k equals to 1, we have 1 plus 2 plus 3 plus 4 plus all the way to plus k. Okay, then we're going to have plus k plus 1. Okay, so here we can have the plus k plus 1 here. Okay, so for plus k plus 1, you just get what is here, you put it here, so that is plus k plus 1. So whatever is here in your previous replacement, you get that and you put it there. That will be your plus k plus 1, and which is equal to k plus 1 squared. So that is the procedure here. So for step 3, you first get this expansion, which is for n equals to k. Okay, you write it here. So that is from here to here. That will be for n equals to k. Then for you to get for n equals to k plus 1, you get your expansion that you had put here. You just get the sequence there. You put it there. And you have what you have on the left side here. Okay, so that is what you do. So now you already know what this is from step 2. So from step 2, hope you can see that. Okay, so from step 2, 1 plus 2 plus 3 plus 4 plus all the way to plus k is equal to k squared. Okay, so from step 2, we just get in step 2. Always use step 2. Step 2 always helps you in mathematical induction. So you're going to replace this, you're going to replace it with this. Okay, so this will basically be k squared. That will be k squared plus what we have here, which is k plus 1. K plus 1. Is this equal to k plus 1 squared? Okay, so is that equal to that? So now here we can expand the right side as well. We can expand the right side. So we see if we expand the right side, we're going to have k squared plus 2k plus 1. So we see that the left hand side is equal to the right hand side. So we can conclude to say true for n equals to k. Okay, so basically those are the 3 steps. Now you also need to make a conclusion. So so of space, I'll write it a conclusion. The statement will be true for all values of n. Okay, so how we started is let me just let's give a recap of everything that we've done so far. Okay, and we wanted to prove whether this statement right here is true or false. Let me see if I can pull up an okay, we wanted to prove whether this statement here is true or false. So we said we can use mathematical induction, and mathematical induction has 3 steps. So step 1 is where we show that the statement is true for n equals to 1. So basically we have what we have here. We replace for n equals to 1, we replace 1 here and here where there is n. So basically we see that this side will be equal to that side. So you just replace n here and you replace n equals to 1 here and there, and you're going to have 1 as we did here. So we showed that left side is equals to the right side. Then we concluded that true for n equals to 1. After you're done with step 1, you go to step 2, which is the assumption stage. We assume that the statement is true for n equals to k, because you're basically just replacing the letter n with the letter k. So the statement will be true, it will be unchanged. Okay, so we replace the letter n for k, so which is this, and we simply said for series and sequences, we can make an expansion on both sides. So here we've made an expansion for series. So the series are an addition of the preceding and the following terms. So we've done likewise here. So the expansion here ends up to k, which is the last number there. And this is equals to what we have on this side. After we are done with that step, we need to show that the statement is true for n equals to k plus 1. Okay, so we have what we've been given here. So now we need to replace with n equals to k plus 1. So where there is n, we replace k plus 1. So here we replace k plus 1. Just zoom in. Replace with k plus 1, k plus 1, k plus 1. Even on the other side here, we replace with k plus 1. Then we know that the sum from k plus 1 to k plus 1, from k plus 1 equals to 1 to k plus 1, is basically the sum from n equals to k, okay, then plus the k plus 1 term. Okay, so this is what we do here. So we just get the sum from n equals to 1 to k, then we just get the k plus 1 term, we add it here. So we say plus the k plus 1 term here, and this will be equals to the left side that we have here. So now from step 2, always use step 2 here for series and all other mathematical induction problems. So from step 2, we have this is basically just equal to that. So we'll replace it here and it will give us k squared plus what we have here, which is k. Okay, so let's see. So actually, no. So here this will be k squared plus k plus 1. Okay, so basically this is not, the left side is not equal to the right side here. Sorry for that mistake. So the left side, I didn't see that there is no 2 here. So there is no 2 here. So the left side is not equal to the right side. So our conclusion here is that the statement will not be true. Will not be true for all values of n. Therefore, the statement is false. Okay, so therefore the statement is false. So the reason why it is false, I didn't check here. So the expansion here gives us k squared plus 2k plus 1, but what we have here is k squared plus k plus 1, which is not equal to that. So that is our conclusion. So have a good evening. We have a long day tomorrow, and we'll see you in tomorrow's lesson. So yeah, so it's good night for now. Remember to subscribe to the channel and leave a like for this lesson.